Hi everyone, this is a video tutorial for primary alcohol substitution reactions that result in the formation of an alkyl halide. So for a primary alcohol, there are going to be two reactions that we want to take a look at. The first one has the primary alcohol reacting with HX in the presence of heat to speed the reaction up and forming our alkyl halide and water. There are two main things about the primary case you want to note. First off, HX can only be HI or HBr. It does not include HCl, and that's just because the reaction happens too slowly when it has HCl in its solution. The second thing to note is that it's an SN2 mechanism. The reason for that is a primary carbocation is too unstable to form, so we won't see the SN1 case, only the SN2 case. The second reaction we see is the primary alcohol reacting with HCl. Now, in order for this reaction to happen, you need a facilitator, which is the zinc chloride. So when you have the zinc chloride in solution, the reaction happens at a rate that is fast enough for us. We additionally will still have heat happen in this reaction. Once it occurs, you form your alkyl chloride and this other byproduct here. So we're going to take a look at the two mechanisms right now. Okay, so let's take a look at an example of the first mechanism. So over here we have our primary alcohol. Remember, we know it's primary because the OH group is attached to a carbon that's attached to only one other carbon group. As always, when we're dealing with these alcohols, the first step is to activate it, meaning we're turning it into a good leaving group, so a group that's easily displaced by whatever nucleophile we have in solution. So over here, my OH, with the oxygen in its lone pairs, will attack that hydrogen, breaking the bond between these two. That results in the formation of a protonated alcohol. So because it would be too unstable to form a carbocation, we're not just going to have the OH2 group leave. Instead, the bromine will come, attack that carbon, which therefore would then kick the water group off, resulting here in our alkyl halide and water formation. Let's take a look at the other mechanism. Okay, so let's take a look at this mechanism. So over here we have our primary alcohol. As always, the first step is to activate that OH group so we can kick it off later in the reaction. So what we have here is this primary alcohol that's going to attack the zinc. Zinc behaves like a Lewis acid. So those electrons from the O can come and attack that zinc, which then causes this chloride group to get kicked off. So that means we're going to form this group over here where we have this protonated O group. So the next thing that can happen, because this is a stable leaving group, is the chloride can come, attack this carbon, and kick this group off over here. So at the end of it, we've got our primary alkyl halide, and we have our byproduct as well. And that's how that mechanism works.